Today we have the pleasure of talking to Mohit Sewak, Principal Data Scientist, the designation that each and every kid dreams of getting in 2020, getting into data science and becoming a data scientist. Principal Data Scientist in no other place than Microsoft. He works out of India Development Center of Microsoft in Hyderabad. Welcome to the show, Mohit Sewak.
Thanks for inviting me, Doctor.
Well, this is Dr. Ishwa Krishnaya, Admissions Director of Great Lakes Institute of Management and currently a faculty in the school. Can you tell me something about your journey, Mohit, before you came to Great Lakes Institute of Management?
I completed my engineering in Marine. So I am BE Marine from Marine Engineering and Research Institute, Kolkata. The admission of that college is again IIT JEE, but it's not like the regular engineering that anyone would do. It's completely hands-on engineering into different types of mechanical and refrigeration and other sort of systems. And after that, I sailed for around 5 years into different seas for different types of vessels into merchant navy and got very rich experiences over there, both in supply chain. Yeah, so I've seen almost all the continents, and then I realized I need to come back to my motherland, India. I came back. I also started a business for a small while. I think an year or so. I broke even that business, and then I realized to scale it better. These are not type of things that I would enjoy. And then I thought I should be doing an MBA. The reasons for doing an MBA were multiple folds. The first thing was I was highly inclined towards two things. Number one was mathematics. That point in time, we didn't have anything as professionally analytics in domains. Apart from, I think FMCG was doing some sort of analytics core statistics department that they had, and actuarial sciences. And in Government of India, it was mostly your census department who was doing analytics. So the one thing was that. The second thing was I obviously needed to change the domain. No one would take actually someone who has done marine engineering into a land-based job. And the third one was I've already got experiences both working hands-on and through a business. Now to get into corporate world, this will be a new thing. So I didn't require to be honest, like a 2-year MBA, but to get more on things, a 1-year MBA, especially focused towards analytics, would have done very good job for me. So I got offers from multiple institutes, but I think the positioning of Great Lakes and 1-year MBA suited best. So that was my journey before, and that is how I actually ended up in Great Lakes.
So for my new students who are currently listening to both of us, listen to his background and then most of your doubts would get over. He comes from a marine engineering degree, then a marine travel background, then an entrepreneurial venture for a short time. He tells he broke even with that venture. It doesn't have any typical corporate experience. Before Great Lakes Institute of Management, his love was for mathematics. Remember that word, mathematics. Students loving mathematics is a very rare thing. And there he is into Great Lakes Institute of Management. And from then on, it just took 1 decade, just 10 years to reach where I initially told you where he has reached, Principal Data Scientist of Microsoft. Mohit, I've seen from your LinkedIn profile that you had a really distinguished set of companies in which you worked in. You were there, I think you had a short stint in Infosys, then you went to Microsoft, then you went to Bank of America, and then finally right now you're in Microsoft. So can you sort of map your journey after Great Lakes and what were your roles in these companies and what were your achievements?
Yeah, that's a very good question because besides the company that has been changed, there has been a lot of role changes as well. And now I'm very fortunate to have seen all the entire spectrum of roles that are possible in AI. So it started with a consultant and then a project and a program manager, obviously a hands-on project and program manager in Infosys. Then I joined IBM. To be more specific, there's a company in IBM called IBM Software Labs, which builds all the softwares that we know are IBM software.
The SPSS,
to be more specific, yeah. So to be more specific, I was a part of IBM SPSS. I was the India architect for the SPSS suite. So I joined there with SPSS statistics, and that is also one of the things that I also developed in Great Lakes and kept practicing it throughout also. And that point in time, I was promoted to, you can say, an initiative which is called Industrial Analytics Initiative. So I joined a product which was spawned as a POC project, but it then became like one of the best-selling product within IBM, which is now called IBM Watson IoT. And that point in time, that was called IBM Predictive Maintenance and Quality, and I was the global analytics architect for that particular product. And then I left IBM and I joined Bank of New York Mellon. That was a captor, so obviously you're expecting a completely different role. A lot of research plus development plus actually execution would be combined together in those sort of roles. So they're coming up with a concept called Nexin, which was your analytics API or APIs for the complete finance industries. And I was trying to put a lot of initiatives to how do you also include analytics and predictive analytics and machine learning APIs or products into that. So we started with a product called, now we call it iSafe, which was into security machine learning. And then we did a lot of other initiatives on process automations, recommendations. So very fortunate enough to actually get into a company which is the largest, you can say, custodian bank, and an end-to-end, like all type of financial services that you know about is something that the BNY Mellon does. And then I got a call back from IBM and they were restructuring and they were coming up with a new product in India, which was IBM Watson Commerce. So I was researching for a lot of different algorithms for Watson Commerce, and that is also a lot of different patents come from. So I think currently I have more than 12 patents. A lot of those patents are for Watson Commerce, some are for I think SPSS, and the other are for Watson IoT, and some are technology patents in general, in AI and other different things. So then after that particular role, that was a mixed role. So one of my initiatives was with the IBM GPS, which is the Global Business Services. That was more inclined towards NLP, Watson Knowledge Graph, custom knowledge graphs, and NLP solutions. And then the other one was again linked with the software labs. That was more inclined towards the, you can say, vision part of deep learning in terms of Watson Commerce. And then when I left IBM, I joined a startup called QIO. This is a startup in Industry 4.0, or what they call is like AI-infused Industry 4.0. So they specialized in building AI products for different types of Industry 4.0 processes. So it could be like ranging from predictive maintenance to process automation, understanding complex hierarchies within the process and the correlations within them. So initially joined them as a reinforcement learning engineer. So at that point in time, reinforcement learning also was not like a very established field in itself. That's apart from OpenAI and some Google-related projects on autonomous vehicles. No one was doing actually reinforcement learning, which has a very pinpoint focus towards application into different types of industries. So I had some experiences on that. In fact, I also had a book in reinforcement learning then, or to be more precise, deep reinforcement learning, which is like a combination of deep learning and reinforcement learning. So I joined them initially as a reinforcement learning engineer, and then my role over the period changed and it became like the lead of the artificial intelligence for building AI products for different types of industries or different types of processes within Industry 4.0. And then I joined Microsoft. In Microsoft also, the role is very much inclined towards security and compliance. And the role is related to research in that. So within Microsoft also there are different types of team. One team is focused towards the R&D or the science part of it, and then it goes into the development. There are like very unique challenges in compliance. In fact, compliance is one of the growing field within the whole gamuts of AI, where AI has touched it, but not as much as other industries. And there's a lot of scope that we are seeing for AI in compliance, and that is the problem that I'm trying to solve over here.
Mohit, today the so-called business analytics and artificial intelligence world is filled with a slew of terminologies. Sometimes we as faculty struggle in trying to understand exactly what are the nuanced differences between these terminologies. So can I ask you three set of differences, and you can probably, from the helicopter view which you're having, give us exactly what those differences are, and the new batch would get that differences precisely. Difference number one. What is the difference between machine learning and deep learning?
Okay, interesting question. It has actually different sort of connotations. So the industrial connotations is deep learning is the highest and machine learning lies somewhere behind. But that's the wrong answer to me. because I also come from an academic background, and my PhD is also in AI. So just to connect things more, you can say technically, machine learning is actually a superset. So anything, yeah, if you're teaching a machine to do anything, is prediction or anything, that is machine learning. Obviously, it is slightly different from data mining, which would actually we'll talk about later. But within machine learning, all these algorithms of our prediction, both supervised and unsupervised, will start coming up. Deep learning would be a sub-part of machine learning, which would deal into using neurons to solve different problems, or deep learning architectures. Now, even neurons will have different ways. So you can actually build an artificial neural networks with just 3 layers: input layer, output layer, and one hidden layer. At that point in time, you will not call it a deep learning architecture or a deep architecture. Until some point in time, there were some mathematical constraints because of which the network couldn't do deep. And even if you make it deep, it will not be able to learn anything. So there were some issues related to gradients and other things in the learning. Now we can actually make networks very, very deep. So the same new artificial neural networks, if you make it deep with a lot of multiple hidden layers in different forms, you can actually put it in different architectures, but it has to be multiple layers. That will when it will start falling into the deep learning. Again, it follows the same hierarchy of machine learning. It will have supervised deep learning also, unsupervised network architectures also, but it will be a sub-part of your subset of your machine learning.
Which brings us to the next question, Mohit. What's the difference between supervised learning and unsupervised learning?
Okay, so let me broaden your question to different types of learnings within machine learning or otherwise. So as you rightly pointed out, the most prominent one is the unsupervised and the supervised learning. So in case if you have a label for the data and the corresponding data for that particular label, and you're just teaching the machine, if I see a particular record and this is the label, and if I give you the next record, what should be the label for it? This in turn is supervised learning. So you have supervised algorithm in terms of the labels that you are seeing. There might be a lot of different other problems where the label might not be available. And you're just teaching the machine learning algorithm to just draw patterns or understand patterns from that data. And those patterns could be later used for different purposes, for either building an algorithm or assisting algorithms or doing anything, and understanding the domain, understanding the data. In that case, it can be called unsupervised. There are different types of other learnings also. For example, one type of learning is semi-supervised, which comes in between supervised and semi-supervised. So you'll start with plain data. You can have some labels around it, and then you'll use different types of algorithms to discover labels for other data. That may fall into the area of active learning also, semi-supervised also. There are strict differences between them. I'll not go into that, but a lot of different themes. Then there's a fourth theme, which is called reinforcement learning. So this is different from both supervised, unsupervised, and semi-supervised, in the sense that you do have something which you can supervise. In this case, it is a reward, but that reward is not tied to specific data. It can be sequence of things that you do, not specifically the data as it is coming up. Each of them have its own application areas and where it should be applied, and the application that you can empower.
The next difference could be, what's the difference between the terminology called machine learning and data science?
Okay, so data science is an umbrella term. So anything about data can come under that. Machine learning, as I said, is a very specific terminology in which it's slightly different from data mining, but anything if you're building an algorithm, whether it's a supervised or unsupervised on the data, especially with the newer technologies, then it will be coming under machine learning.
Once upon a time, ABC, when we were in school, had its own connotations. Today, A stands for analytics, B stands for business, and C stands for the world of computers. Without these three coming together, there is no learning at all today. So can you try to hierarchify the importance from a business school point of view of analytics, algorithms, and that world, business as we understand from a pure business school perspective, and the relevance of computers and computing? ABC.
Okay. I think we are forgetting the fourth part, which is D, which is the data, because without data, you cannot run businesses.
Oh.
So nowadays, we have seen the era where you'll just come up with very fancy algorithms. You'll try to put it on the limited set of data that works or doesn't work. So you try to force fit your insight into what you have developed. Nowadays, things are changing because we are discovering that we are using just 1 or 2% of the entire data that is possible. because earlier it was an assumption that this the other data, which is also now known as dark data, there has been like different terminologies to it. It was called like big data earlier that you cannot mine or something like that. But now there is a more of a like a consensus that that can be called dark data, because now there are different technologies that you can still mine. And if any of the existing technologies couldn't mine that particular data for insights, that is dark data. We do not know about it. So nowadays there's more realization that there's a lot of dark data, and we need to find technologies to get insights from that. And a lot of different businesses could benefit from those insights. So we saw that especially in Industry 4.0, where they had like a lot of different sensors. We couldn't get the meaning of those because they speak a different language. We could see like one sensor series in isolation. But it becomes very difficult to combine different sensors to see like what when the machine is going to fail, or even if the sensors tell when the machine is going to fail. We're seeing that trend all over. In the case of vision, also now we are trying to make the machine learn what we see. And most of the inspirations that we are drawing is from our own eyes. And that is how our own senses are now powering these, all the insights from our own senses are powering these algorithms. So there was data earlier, we couldn't analyze it the way that we are doing. Nowadays, the trend is on end-to-end deep learning. That trend started with neural machine translations, in which we found it much better to have like an end-to-end model to do from one language to another without actually getting embeddings and serializing them into different algorithms. And that sort of insight is now being copied to different other algorithms and different other applications also. And nowadays, I think we have used at least a superhuman capabilities in terms of what NLPs could do, or bigger models like OpenAI GPT-3 or Microsoft Turing or Google BERT could do in the space of NLP. So I think when you start combining all these fours, which is like the analytics or these algorithms, the business part of it, the application area, that has to be very good. Because right after, if you have just done your MBA and you're getting out, you have an inclination of just applying something that you know. Like if you are a hammer, you just find a nail everywhere. So getting the right applications of the business, then obviously the C is the computer, which is nowhere allwhere with us, and the D, which is the right data for that particular type of applications. In the sequence, it may not be exactly ABCD. To my understanding, it may differ from different person to person. The first thing starts with business. You try to understand which is the ROI drivers in that business. Obviously, then the technology might not be ready for it. So either the algorithm might not be ready, or you might not be ready with the compute. C part is something that people ignore, but especially in the case of deep learning and dealing with very, very large models, we see compute is now becoming a lot critical. We have the models now that can work, but to scale them to that level that it can actually, web scale level or the complete enterprise scale level, we do not have enough compute, and a lot of things actually get rolled because of the budget that the compute requires. You may actually require data center level compute just for some applications. Even in the enterprise, I'm not talking about like high performance computing, but even at the enterprise level. And then fourth is the most important thing is the data itself. So that is how I think mastering these fours can actually lead to very good problem solving in all the types of businesses.
Mohit, these days we find there's a lot of overlap between what B schools used to teach and what good tech schools used to teach. B schools used to start obviously from business and then come down to analytics, then come down to technology. Today we're thinking of moving all the way down to devices. A good tech school always starts with solid state physics, devices, then go to technology, and slowly now they are inching their way upwards and competing with other analytics. Hopefully they don't come to business. So where do you see this interplay happening, and is it a good thing? The trend that we all tend to see teach more or less the same thing these days.
Yeah, so when I came to our giant MBA, I found that many people had an inspiration behind joining MBA that they do not want to code. And that is what the logical progression that they saw, that they wanted to get into managerial lines and stop coding and get to what they seem to believe is like a more value-added work in industry. I think that has taken the industry 360 degree now. And nowadays, what I see with different industries is the core value-added things are considered to be people who are hands-on and who actually code, irrespective of their degrees, irrespective of their number of years of experience, irrespective of their background. Even if you are an engineer and a mechanical engineer, you cannot code. There's a limited value that you can add. Even if you have grown up in your career, you have become an architect or even a managerial person, and you do not understand the technology, there's limited value that you can add nowadays. Despite the fact that not everyone is expected to code these days, but everyone is now expected to understand what is being coded or how do businesses change. So every business is now a digital business. And even if you believe that you are in an industry that is not a digital business, very soon you'll be out of your business itself. We have seen this industry after industry. Each industry has now been transformed by a newcomer who was not supposed to be an industry player or that industry player. He was supposed to be like a digital player. And they revolutionized that industry so much so that even the incumbents of that industry are nowhere close to their market capitalization. So nowadays, each industry is a digital industry, and the recipe of the digital industry is be hands-on. Even if you are not hands-on, be very abreast with the technologies. So you have rightly said it that now there's no different streams of management of technologies, of even within technologies like say technology X, technology Y. And in fact, nowadays everyone is trying to add value and become a problem solver. And it only depends upon how far you go to solve that particular problem. And more you keep barriers to yourself that I'm a technology institute, I'm a management institute, that is like creating a lot of hindrance to how much value you can add to the final product.
So dear students, those of you who are currently thinking you're going to struggle with R, struggle with Python, and tell us that, well, we have come to a business school. Why should we learn coding? You get the answer from the principal data scientist of Microsoft. You do not do coding, you are on the way to become a dinosaur. You are on the way to your own extinction. There is no business today which is not a digital business, and there is no level in hierarchy today where you do not do coding. Did I hear you right, Mohit? Can you reinforce what I told? That's exactly what you told the kids, right?
Yeah, right. So currently I have like more than 15 years of experience, and I still code day in and day out. And I do not keep any minutes before me that I shouldn't be doing that. Yes, of course, whenever I see like this, I can spend time in much better way strategizing for the product, for the features. Obviously, at my level of experience, I expected to do that. But at the same time, I find out time to be hands-on and try to put those technologies back to what I love, like putting it on how it adds real value. So the more experience you get and you gain, the more is the responsibility on you to add value to what you conceive or is the right feature for the products that you are dealing with, or the industry or the business that you're dealing with.
Continuing on our conversation, Mohit, today the key word is innovation. And without innovation, we are just not going anywhere. And as someone like you who has got a lot of patents and a very, very creative bent of mind, can you tell us the importance of innovation today in the area of technology and in the area of management in general?
Right. So I think there is a lot of commonality between what we see as value in industry. So in Microsoft also we have like a keyword which is responsible AI, and a lot of that responsibility comes from diversity and inclusion. And that I believe is also something that brings about innovation and creative mindset in any enterprise. I'll take the example of myself. So as I explained, my background was not into IT. I am a core engineer working hands-on on different types of technologies. In fact, I left the core IITs just to follow my passion on learning different types of engineering, be it mechanical, electrical, electronics. So I saw how these technologies actually amalgamate into different forms, to different creative forms. So in one form, it may actually give birth to one particular product. In second form, it will give to different types of products. When you combine the knowledge of business administration and business management to it, you start finding out business problems which could be benefited from different amalgamations of technologies. And when you add to it your core knowledge of mathematics, analytics, and machine learning, and then you add to it like your prowess of the coding, that is when it takes you your eagerness a bit forward to actualization of the outcomes of it. So that is what I believe is driving the innovation for me. So all the patents, if you see of mine, are coming up from the different amalgamation of technologies which might be used in some other industry, but I try to put it into a completely different context that no one would have thought of earlier. And it solves real business problem. The good thing about that is also that it gives rise to high business value patents. So just number of patents doesn't count till they are not like high business value patents. And those are also the things that I talk about in either my YouTube channel or my books or my different papers, the actual applications of technologies and mathematics around it. So I think even to drive the diversity and inclusion into your real products and real businesses has a real value.
One last question to you, Mohit, is what would be your advice to the current MBA students based on your own learnings from Great Lakes and your own career path in the last 10 years? Where would you advise the current youngsters? What should they do? How should they plan? What should they study? And what should they focus on?
Okay, thanks. I think this is a very good and very relevant question because I see in the current times, analytics is at its peak, it's trending. And I see everyone is getting forced into it. So much so, even if they do not, and they're not inclined and bent towards either mathematics or coding, they are trying to adopt a complete career in analytics. And when I say adopt a complete career, I mean like as a primary career in analytics, which I don't think is the right thing, because if something is at a peak right now, not sure it will be at a peak 10 years from now. No one can predict that. The second thing is, in doing that, in catching up onto those things, many people I've seen forget their strengths, what they naturally enjoy and love to do. I am here not because analytics was at great at that point in time, and I was thinking like, okay, I can earn like this many if I get into analytics, and that is why I got into analytics. That didn't happen with me. I came into Great Lakes and then I excelled from here because of my natural passion in mathematics, coding, robotics, and other things. And that was a type of MBA that I wanted to do. And the first job that I got may not have much to do with analytics. And I kept on finding avenues where I could apply analytics to be better at my job and my role. And that is how it started developing, and that is how I started benefiting within my role. So the last thing is, you do not have to become or try to fly high if you are a fish. So if you are a fish, find the cleanest water and a company that can swim deep with you, and that will sail you through. So try to find your strengths, what you love, and try to just become number one in that particular thing, and you will definitely succeed in life. If you do not like analytics, just don't run after it. If you like analytics but you are scared or you do not want to make it as your primary career, just relax. Just learn it and try to apply it in whatever you do best. So the bottom line is, understand yourself, understand your strengths, just focus on your strengths. Just forget the weaknesses and other things, or the buzz around or what's around. Just focus on what are your strengths, keep building on your strengths, and you'll definitely succeed one day.
Thank you, Mohit Sewak. That was Mohit Sewak, Principal Data Scientist, Microsoft India Development Center, working out of Hyderabad, talking to us and sharing his thoughts on how within a 10-year span, a boy who was just a marine engineer with no technology background, who was roaming all over the world, enjoying his life in a ship, transformed himself through a series of brilliant companies, Infosys, IBM, and then finally to Microsoft, and currently is occupying the pride of position as a top-notch data scientist of this country. Thank you, Mohit Sewak.
Thanks again, and the best wishes with all the students of Great Lakes.
Thank you so much.